Hey, on this video we're going to look at how to solve a quadratic equation by completing the square method. So these are the steps involved to completing the square method. First you get your quadratic equation in the form ax squared plus bx plus c equals to 0. Then you move c, this c right here, to the right hand side. Then if a is not equal to 1, you divide both sides of this equation by 1. If a is equal to 1, you can skip step 2. Step 3 says to add the quantity b over 2 squared to both sides of the equation. And when you do that, you create a perfect square trinomial on the left-hand side. Then you can easily factor the left-hand side into x plus b over 2 squared, or rewrite it that way. It will always be true that the left-hand side equals to x plus b over 2 quantity squared. And then it turns out you have something squared equals something, similar to this right here. And you finish this off by taking the square root of both sides. Here are a couple of examples of solving by completing the square. If they say solve by completing the square, and they give us this one, x squared minus 2x minus 4 equals to 0. Let's do this one. Right here I see a is equal to 1, b is equal to negative 2, and c is negative 4. Alright, move c to the right hand side is the first step. So we say x squared minus 2x is equal to 4. And then it says if a does not equal to 1, divide both sides by a. But a is equal to 1, so I don't have to do that. I could divide both sides by 1, but it would look exactly the same. Then step 3 says to add the quantity b over 2 squared to both sides. So in this case, my b is negative 2. I need to add negative 2 over 2 quantity squared to both sides. This is a negative 1 squared, which equals to positive 1. This is what I like to do. On the left-hand side, I leave it looking like this on the left. On the right-hand side, I don't mind if I go ahead and square it, but I'm adding the same quantity to both sides of this equation, which is legal. So I'm going to add negative 1 squared on this side, that's equal to 1. On this side I'm going to add 1. Thus is the same quantity, so that's okay. The reason I do that is because the next step is to factor the left-hand side into x plus b over 2 squared. What I see in this parentheses is b over 2. So this factors into x plus negative 1 or x minus 1 quantity squared. That's x plus b over 2. This is equal to 4 plus 1 or 5. Now most of the questions I get about completing the square is, what happened to the 2x? How did I just rewrite this left hand side into this? Did I just ignore the 2x? No, I didn't. If you take x minus 1 squared and you multiply this out, you'll find that it multiplies out to x squared minus 2x plus 1 if you FOIL or distribute that. So it's accounted for in this rewriting. Now I observe that I've got something squared equals something. I will finish this process off by taking the square root of both sides. The square root of x minus 1 squared is simply x minus 1. This is equal to plus or minus the square root of 5. What I just did was I took the square root of both sides of that. I'm solving for x. X is going to equal to 1 plus or minus the square root of 5. And you can write this as x is equal to 1 plus the square root of 5. X is equal to 1 minus the square root of 5. Okay, here is another example of by completing the square. Let's have a look at this. What if they give me something like this? 2x squared plus 6x minus 3 equals to 0. So it said right now a is 2, b is 6, c is negative 3. The first step is to move c to the right hand side. So I'm going to move 3 over. I'm going to add 3 to both sides. And then it says if a is not 1, divide both sides by a. Well, a is 2. It is not 1. I need to divide both sides of this equation by 2. On the left-hand side, I'm left with 2x squared divided by 2, or just x squared. 6x divided by 2 is 3x. Over here, I'm left with 3 over 2. Now I'm supposed to add b over 2 quantity squared to both sides. At this point, after I divide by 2, I have a new b. My b is equal to 3. So I need to add b over 2 quantity squared to both sides. That's going to be 3 over 2 quantity squared. That's what I'm going to add to both sides. On the left-hand side, I leave it looking like this. On the right-hand side, I don't care if I go ahead and square that. That's going to be 9 over 4 when I square that. So over here, I add 3 over 2 quantity squared. Over here, I add 9 over 4. The left-hand side, this will always factor into x plus b over 2 squared, x, and whatever I see in here, plus 3 over 2. If that bothers you, then you should say x plus 3 over 2 squared is x plus 3 over 2 times x plus 3 over 2, and multiply this out. You're going to get x squared plus 3 over 2x plus 3 over 2x plus 3 halves times 3 halves, which is 9 over 4. 3 halves plus 3 halves is 6 halves x, or 3x. So I want you to believe that this is not cheating. X squared plus 3x plus 3 half squares does factor into x plus 3 half squared. On the right, we simply need to add these two fractions together. 3 over 2 plus 9 over 4. The lowest common denominator is 4. I need to multiply this by a 2 over 2 in order to get a denominator of 4. This becomes 6 over 4 plus 9 over 4. Now I can add these. 9, 10, 11, 12, 13, 14, 15 over 4 is what this combines to be. Now I have something squared equals to something. I simply take the square root of both sides. The square root of x plus 3 halves squared is x plus 3 halves is equal to plus or minus the square root of 15 over 4, which can be thought of as the square root of 15 over the square root of 4, which is 2. I'm still solving for x. I need to subtract 3 halves from both sides. So this is equal to negative 3 halves plus the square or minus the square root of 15 over 2. Negative 3 halves plus the square root of 15 over 2. Negative 3 halves minus the square root of 15 over 2. All right, we're going to do one more. We're going to solve this using the quadratic equation, which is this formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to solve this same equation and check my work using the quadratic formula. So we got 2x squared plus 6x minus 3 equals 0. It is very important that you have a 0 on the right-hand side before you begin this process, because otherwise you're choosing the wrong a, b, and c. So a is equal to 2, b is equal to 6, c is equal to negative 3. Now we simply plug this into the formula. X is equal to negative b, negative 6, plus or minus the square root of b squared, 6 squared, minus the number 4 times a, which is 2, times c, which is negative 3. And this is all over 2a, which is 2 times 2. X is equal to negative 6, plus or minus the square root of 36. A negative times a negative is a positive. 4 times 2 is 8. 8 times 3 is 24. This is all over 4. X is equal to negative 6 plus or minus the square root. 36 plus 24 is a 10, 3, 4, 5, 6. This is a 60 over 4. Let's see. Now I need to try to simplify this. Are there any perfect squares in a 60? I think 4 goes into 60. 1, 4, 20. Okay, I can rewrite 60 as 4 times 15. And that is helpful because I can take the square root of 4 and get a whole number. So x is equal to negative 6 plus or minus 2 times the square root of 15 all over 4. And there's a common factor in the numerator and denominator of 2. So I can factor out a 2 from the numerator, leaving me with negative 3 plus or minus the square root of 15 over 4. 2 goes into 4 2 times. So I get this answer. X is negative 3 over 2 plus or minus the square root of 15 over 2, which is, hopefully it is, the same exact answer we got a minute ago when we did this problem by completing the square.